Hey folks, I'm Sung. Such a pleasure to meet with you. Thanks for your patience here. I'm going to talk about a lot of stuff today, and so pray to the demo gods for me because I'm doing 3 live demos. There's a lot of browser tabs open, highly dependent on some API connections, and so just say a little prayer for me right now. But overall, what this presentation is not, because I talked with a couple of you, this is not going to be a DBT 101 plus machine learning. I'm pretty much going to do a speed run of what DBT is, just to get a baseline of how that works in the overall workflow, and then I'll just zoom right into just hands-on demos here. All right? But first, a little bit about me. You're probably wondering, who the heck is this guy? What I should care about? What he's talking about? Well, one, I've been working at DBT Labs for the past year, and I've been noticing just kind of this nascent trend that data scientists and analytics engineers want to have a better working relationship with each other. Right now, the workflow probably looks like hot potato, right? And a little bit of tinge of condescendingness between the roles at this point. And I hope, just what I demonstrate here can, alleviate some of that tension and make, both roles really enjoy working with each other. And also, fun fact, I make songs on Spotify. Check me out. Look at the QR code. You can be the reason I make like 5 cents this month, all right? But moving on from there, our agenda today, again, I'm going to do a speed run of what is DBT, what is DBT not. I'm going to talk about why ML workflows are broken today with a very clean anecdotal example, and then I'll just go straight into the meat and potatoes of what different tools and integrations are looking like today to solve some of that gap in the integrations here. So overall, what is DBT? We are the T in ELT, and so that stands for extract, load, and transform. Step 1, some raw data is extracted from Salesforce into Databricks. All right, that ingestion job is done. Step 2, you run your DBT transformations using SQL with automated out-of-the-box testing and DBT docs and schedule, and you move on with your life. DBT's job is done. Step 3, with those golden data sets, you use a BI tool like Looker, Tableau, Power BI to point to those golden data sets hosted in Databricks, and that's it. That is your BI data pipeline. And you notice here the ML piece is missing from this so far, and I'll talk a little bit about that. But why DBT matters to this space is because without DBT, you probably have a couple options here. One, you're using Airflow, and you're doing a lot of advanced stuff just to wrap some SQL around. And when things break, it's a very not fun process. Step 2, I kid you not, I've literally worked with a customer that had 1,000 lines in a stored procedure. No one wants to babysit that for the rest of their career. And so when that person leaves, nothing changes, right? And so instead of having this hot potato experience through DBT, I think the quintessential question we ask in any data pipeline workflow is, when things go wrong, how painful is life? How painful is my job until I quit, right? And so we're the reason why, hopefully we prevented a lot of people from quitting their jobs, right? And actually enjoying building the data pipelines that they're proud of. And so instead of playing hot potato, oh, I think this data is funky, or I did a select star from limit 5, and I don't quite know how this data works, you have automated testing, so it's like, hey, if I'm going to yell at you, we're going to have an intelligent conversation about it. I know this is wrong for this specific reason, and I know you know how to fix it through SQL, right? And so our entry point together to figure out our problems is SQL, instead of just convoluted Excel pivot tables, random Scala code, random rep SQL, and store procedures, right? But again, you notice here, the data scientist is missing from this piece because we haven't really, addressed that audience yet, because that wasn't our intentional goal. But going further into this and zooming in, again, this is a speed run here. What is DBT and how does it work mechanically speaking? If you want a full in-depth demo, meet me at the booth in the expo later today. But in the next 30 seconds, how DBT works is you just get to chain your SQL together. And so instead of going through step by step, hey, step 1, run this SQL statement. Step 2, run this, 3, 4, 5, 6, 7, 8. You just get to declaratively state, through this template language ref, it automatically knows the DDL that's compliant with Databricks, and it knows what schema to draw into. So when I do all this beautiful, great work in dev, you're probably thinking, oh, do I have to copy and paste the code and do a control, find, and replace for the dev into prod? Not at all. Your same code works across both dev, QA, prod, whatever environments that you want to care about. And so that's probably one of the biggest reasons why people love DBT today, just because I get to chain SQL together, like how I think about my data workflows today. So let's talk about the example of Baton pass, and this is where I introduce how a data scientist fits into the overall picture. And so let's say I am a marketing person, right? And we're at a relatively mature state in our business. We have thousands of customers. We've been noticing about 2% churn every year. And it feels like, hey, as the marketing person have enough intuition, I think we have enough data based in Salesforce and all these other whatever tools that we're using to predict churn, right? Think things like NPS score. Think things like usage over time. And so I tasked the data team, hey, I probably like submit a Jira ticket or something like that, right? Like, hey, can you show me, what churn will look like forecasted this next year based off some intuitive variables, right? And then they're up to the task, right? That's how there's typically that kind of adrenaline and momentum, propelling this team forward. Is like, okay, I know what to do. I'm going to draw this data from Salesforce using Airflow, for example, whatever API calls you have. And then from there, we baton pass it to the analytics engineer, and they're like, I know exactly what to do. I'm going to transform it. It's going to be real juicy. I'm going to go through bronze, silver, gold, and people are going to love me, right? And then from there, I baton pass it to the data scientist who's probably using like a Jupyter notebook, for example, or a Databricks notebook, for example, pre-processing it, training it, making sure the inputs for the feature sets are formatted correctly for the ML algorithm. And they're like, yeah, like based off these like particular features, we know these very specific customers may churn because of these qualities, right? And so like, okay, everything's good to go. And then they showed it to the marketing person. Everyone cheers each other, pats each other on the back. Things are looking good. 2 weeks later, 2 customers churn out of nowhere that weren't on the forecast. And the marketing person's like, what's going on here? I think your ML model is broken or the data is broken. And then we check, it's like, yeah, like they definitely churned and we don't quite know why. And then I intuitively noticed, like just at a glance, looking at some documentation, I just go like, oh, hey, data team, did you include NPS score in your model? And then all of them just have a dumb look like, oh God, and they're all frazzled, right? And so you're probably thinking like, okay, how do we fix that, right? Oh, we start playing a blame game at this point. Oh, I think the data engineer didn't ingest that raw data. They didn't include the NPS score. And then the data engineer goes into the logs, probably does a select star from limit 5, and the data was like, no, I ingested that. And then now it's time to blame the analytics engineer. Oh, I don't think you included that in a staging model or something else downstream. And I go like, oh, no, or sorry, I didn't really include that, but they try and like do a diplomatic like hedging of like, oh, I can fix that right away. But then it's like, oh, hey, is it the data scientist's job or the analytics engineer's job to like cascade those changes all the way to training and Jupyter notebooks? And you notice like in this story, like there's a lot of frazzled, hot potato energy. And then while I'm an analytics engineer and I'm arguing with the data scientist, while we're arguing for 2 weeks in a row about who should fix what, you know what the marketing person has done? They've hired someone else to be shadow IT, a data analyst that makes an Excel pivot table with the same data that you've been using, and they move on with their lives. And everyone forgets about the project even existed. And so I'm gonna pause there. I just wanna raise of hands, like, have you encountered like a similar story that I just illustrated today? I wanna see if I'm on the mark here. Can I get a raise of hands? All right, a couple of you. This isn't to shame you, I just wanna know, all right? Perfect. And so I think all of us can generally agree, even if you haven't experienced it, I'm sure there's like a little bit of like a trauma response from seeing something like that, right? Of like someone not liking your data, blaming you, you take too long, they do their own thing, right? And so I think ultimately boils down to this question: who makes data and machine learning pipelines maintainable over time when things break? Because ultimately what we care about isn't like how fancy our code is or fancy our algorithm is. I want that marketing person to trust me. When I say these 2 customers will churn based off these features, they go like, okay, I believe you, Sung. I know what to do next. I'm gonna schedule meetings with them, right? Versus like, oh, that's cute. I'm gonna rely on my data analyst that just made a really cool Excel table, That's what it looks like today. So let's imagine the future together a little bit. I'm not here to give you a definitive answer. I'm here to just like explore in the wild and learn in public with you all. And so just be prepared to raise your hand later to let me know, hey, I really love this, or actually this sucks. Like there should be something different than what you're showing me right now, all right? So with that in mind, let's think through a couple questions that you intuitively think through to solve this problem, right? I'm gonna zoom in on the baton pass between the analytics engineer and the data scientist. Data engineer, we're cool with you for now, all right? But do we need a better developer notebook? Because I know 80% of the time, data scientists work with Jupyter, Databricks, a million notebooks under the sun. What does it look like to just like inject some adrenaline and make that more of a steroidal experience, right? 2, should we increase the SQL surface area to build ML models? And we're already seeing that. You're gonna see a little bit about that with a continual today. Step 3, should we just leave that to non-SQL interfaces like Python and just live with where we're at, but just have better processes and communication? And then does this have to be an either or future? And a spoiler alert, I think all of these can work complementary together, but we'll see. I want to hear your sentiment later on. But step 1, and this is for you in the live stream, if you're like, look, I got to dip out because I'm multitasking during meetings, take this QR code, watch it on your own time, bookmark it how you will. But overall, I'm going to role play, like pretend I'm the ML engineer in this context, right? Pretend we're starting with Hex, and right now it's Hex connected to a Databricks SQL endpoint at this point. And so it'd be nice of like, hey, like I'm using dim customers in my star schema data model to make some really important decisions. I probably have some top of mind questions of like, hey, when was this last updated? how fresh is this data, and how is this tested? You know what I'm probably going to do if I don't have this integration I'm about to show you? I'm going to open up 10 browser tabs and still second guess myself as I go through each cell, querying and basing off this data, right? But instead, what if I had just some quick and easy context to go like, hey, I'm starting off with dim customers. Apparently, there's this integration with Hex that I can just look at, some cool things here. I'm going to go here, and I see some green check marks. Oh, it looks like something was ran 2 days ago. Oh, hey, looks, there's 2 tests. Oh, hey, there's some plain documentation here. And I noticed there's some cute little hyperlinks. Like, what the heck does that really mean? I click on here, and those of you familiar with dbt and dbt docs, it takes me exactly to that point of view. And so pretend this is my first time ever touching the dim customers table. I just know it's important to start as an input to my algorithm. I just go, OK, so this is where it exists within Databricks within this schema. This is the table name. OK, here's all the plain language descriptions of how it's working. If I'm super skeptical of how this code is working, I can literally copy to clipboard, go over here, run it in my interface, and then fingers crossed, the demo gods are on my side, and something appears. And Shazam, oh yeah, this is the table that I was looking for. Perfect. Now I get to go back here and keep doing analysis. Let's take it a step further. I'm like, OK, that's one table, but what about 2 or 3 or 4? I'm going to go back here. I'm going to go back to dim listings, and I notice, hey, it was run as part of a job, but there were no tests. And I want some more documentation just besides the metadata of int string and all that other fun stuff. So I'm going to go here. I'm going to go here. And it points me to the exact run within dbt Cloud that powered this job. And so when I think something looks funky, instead of just generically yelling and being condescending towards my analytics engineer, I can have a much more intelligent conversation with them. I can go hey, look, appreciate you making dim listings, but it looks like you didn't add tests. Do you mind adding tests just to make sure I feel comfortable using it? And the analytics engineer knows exactly what to do. Oh, I got you, Sung. I totally empathize. Let me fix that right away. And you notice that whole role-playing scenario, what took 30 seconds to a minute versus what probably looks like a very belligerent 30 minutes in Slack today, right? And so I'm going to pause here. Do you like what you're seeing so far? Could you imagine this solving the problem that I illustrated in that anecdote today? I just want a quick raise of hands here. Yeah? OK, that's good. That's good. Beautiful. Quick shout out to the Hex team and Claire specifically for helping ship this integration. Really appreciate y'all. And so, yeah, that's one way. But you're probably thinking to yourself, this is cool, but it doesn't go all the way because it's more than just the inputs of this data. It's a lot of the context, and this isn't going to be the singular point of failure here, right? Totally get that. That's where we move on to the next thing. Again, for those on the live stream that are multitasking and need to watch this later, hit this QR code. But in the meantime, what if instead of context switching between 2 different tabs when I'm doing my development across analytics engineering and across data science, I just have everything integrate into my dbt context? Because all my analytics engineers and my data scientists know how dbt works and flows, right? And so this is where continual comes into play. And so let's pretend I'm trying to predict customer lifetime value. Who are the customers I should follow up with because they have the most ROI to spend money on XYZ product, right? And so step 1, I'm using the same dbt I know and love, but because you're probably thinking oh, do I have to add a bajillion configurations to make this work? Thankfully, the answer is no. So quick shout out to the continual team for making this feel so elegant. But overall, what I do is, hey, customers table, that is my input to my ML algorithm. All I'm going to do is say, hey, this is the feature set. And so all the columns down here are going to serve as the inputs to my algorithm to say, hey, these are quantitative and categorical variables that are going to influence and be weighted as to determine what customer lifetime value is, the name of the entity and the index ID. From there, I have a customer lifetime value table where I just serve as a placeholder. But overall, this is where the meat and potatoes of the continual configuration takes place, where I say, hey, I want to build an ML model. I want to predict active lifetime spent. Here's the name of the entity. Here's the target customer lifetime value. I want you to predict that result side by side to the actuals. And then from there, you're thinking OK, so what do I do from there? From there, I run a command that looks like this to make sure I compile the SQL and I create the tables, because that's going to be a continual starting point for the ML models. So fingers crossed these APIs work just right. And then from there, it'll compile things based off those continual configs to make continual configs that are compliant so it can push it into continual cloud and build a bunch of ML algorithms out of the box for me. All right? And then once that's done, I run a command that looks like this. It's continual run. It picks up these config files, pushes them into my managed continual experience, and then runs a race between, I think, like 10 out-of-the-box algorithms. Keep in mind, my experience comes from like the data engineering workloads. Some of the ML stuff is a little bit gibberish to me, so I'll do my best. If you want more of like an in-depth follow-up on like how continual works, there's a couple of continual folks back there with t-shirts, and you can go to the booth over there. But overall, this will work. It'll send me a URL to say, hey, Sung, like, go here, no changes detected. But let's say, hey, I want you to rerun the race for me. I'm going to go here. I'm going to click rerun. And it's going to take a bunch of steps for me. I already ran this ahead of time, so I'm not going to waste your time looking at a bunch of spinning wheels. But overall, after this is done, what's really cool is this. It's like, OK, here is my customer lifetime value table. Nothing special yet. But what's really cool is that Continual created this table in Databricks on my behalf. And so right now it's going to preview it real quick, but it's going to put the actual customer lifetime value side by side with the expected. And from there, I can even just eyeball. Even if I'm a business user, I have some level of trust because I'm not looking at like root mean squared error. That will never mean anything to me as a business user. But if I look at expected side by side to actuals, I'm like, OK, that makes sense to me. You're about like 0.16 decimals off. Ooh, it looks like your ML model performs pretty well. Yeah, I think I can generally trust this, right? And let's say I'm an analytics engineer that just wants to upgrade my skill set and get more intelligent about how all this stuff works. I can click over here. I can look at the training history over here. And then I get to see the race that took place. At a glance, it tells me, hey, this weighted ensemble model is the one we're going to push into production so that when you keep running your continual and DBT jobs, it'll continue to predict using this weighted ensemble model. And then it also tells me why the others lost because of other like metrics along the way. But overall, I didn't need to know super fancy Python skills. I just used the DBT I know and love and probably like copy and paste some code snippets from a continual getting started and move on with my life. But again, like this isn't going to be a silver bullet because what if I just generically chose this but didn't provide enough data, right? If I only input 500 rows, no ML model is going to be good enough, right? And so it doesn't replace me being smart about how I use ML in the first place. So I'm going to pause here. I want to get like a quick rating. Like, do you feel like this is headed in the right direction to solve that problem between analytics and data scientist folks? Just a quick raise of hands. OK. All right. About the same. All right. All right. I saw the continue folks raise their hands. That's good. All right. Let's see. Other than that, I'm going to move on to the next step over here. What if you're like a lot of like data engineers and data scientists like, look, Sung, I just want to get my hands filthy with VS Code and Python. I do not touch notebooks. I do not touch managed services. It's like, I hear you. I get that. And so I think the biggest thing about DBT is how do we make sure we integrate lineage across SQL workflows and across Python workflows, right? Because it's hard. You're kind of like doing rule of thumb kind of guessing games of like, oh, this Jupyter notebook or Databricks notebook is powered by these 10 nodes. I kind of think maybe, hope for the best here. Click run. Let's move on with our lives, right? But instead of playing those guessing games, what if we had something that looked like this? And huge shout out to the FAL folks, specifically Burke and Gorkum. Thank you so much for all your help with this. But what if I could just integrate natively Python, arbitrary Python with DBT? And to be clear, this is not the same functionality Drew talked about earlier today. This is something completely different. But overall, I'm going to import some packages in this Jupyter notebook. I just want to kick the tires around, right? I pointed to my DBT project in my directory, and I just want to list my sources. And so I go over here, and I see this really fancy list. Pretend it's my first time using this. I'm like, what the heck does that really mean? I go over here to my Airbnb sources, and this is just all dummy data, to be clear here. And I go like, oh, hey, it was able to pick up the configuration file in this YAML and show me in a really nice and easy-to-use list. So you're probably thinking, OK, that's cute. It's not that helpful yet. Let's keep scrolling down. This is where the power happens. What if a ref statement to the SQL analytics engineer meant the exact same thing, literally and mechanically, to the Python data engineer, data scientist, right? So I'm not making arbitrary calls to like schemas. All I have to point to is the name of the SQL file minus the .SQL, and it'll instantly know to point to this. And then from there, it's loaded in a data frame in memory, and I'm able to see the preview. And what's nice about this is now I can add arbitrary Python to do some sentiment analysis. Now again, to my earlier point, you're probably thinking like, oh, that's cool you can do Jupyter Notebook. Like, I want this scheduled. I got you. What if I run a command that looks like this? that runs my dbt code in sequence, in proper order of operations with my Python predictive code. And you're probably wondering like, okay, cool, Sung, you ran that, like what black magic is happening? Nothing too crazy. All I'm doing is adding a meta tag here, similar to how continual injects their continual configurations. And I pointed to a Python file, and you're probably like, hey, what the heck is that Python file? It's this. It's basically the Jupyter notebook that looks like this. And then from there, I get to move on with my life. Now, while this is running, we'll have to just get a raise of hands like, how many of you think this is a step in the right direction to solve that problem? Ooh, okay, nice, nice. All right, well, I already ran this ahead of time, but at the end of the day, TLDR, you get the same printed results of the data frame that you care about. And so when I want to do this and when I want to rerun, oh, hey, I need to rerun everything, I don't have to context switch across like 2 tabs between my dbt cloud stuff and what's it called, like my Jupyter notebooks or Databricks notebooks. Everything happens within a single interface. And so when things go wrong, like both me, I as the analytics engineer, and the data scientist can have an intelligent conversation on a united interface to have this conversation. All right? So I went way faster than I thought, but what outcomes matter in this whole thing? Because I think it's easy to go like, oh, this is a fun little show and tell, Sung, but I think what really matters is, you know, when the CFO or the business analyst or the board of directors is asking, hey, what's revenue by month for the past 12 months? They do not care how cool your code is. Let's be honest about that, right? They're not like, ooh, I love that scala that you wrote, right? No one does that. But what they do is like, hey, like, did you provide this result consistently with quality and make sure I as a CFO don't have to open up 10 browser tabs to validate that this is correct, or in a 30-minute Slack back and forth message, right? And so, you know, what ultimately matters to zoom in to solve like those kind of like bigger meta business problems is like when something goes wrong, it's less playing hot potato and being condescending towards each other and going like, hey, like, let's solve this together. I think these tools will help us isolate what went wrong, and now we know what to do about it. 2 is really around people being proud of their work. I cannot tell you how many times people, you know, submitted a Kaggle competition ML submission or like made a really cool Jupyter notebook only for like a marketing or finance person to go like, oh, that's cute, and then never actually use it, right? And I hope all of us have like really like cool, beautiful, recent stories of like, oh, I'm so proud of the work I did because this marketing person actually reached out to someone because of what I provided. Oh, like the finance person said like, oh, they were able to forecast their numbers better because of my inputs in the ML algorithm. And honestly, like, I hope all of us get to work on really interesting problems because 80% of our data culture and industry is about like plumbing, right? And I think it's time to evolve past that and like self-actualize a little bit. And honestly, what's most important is that people like actually use our work, right? I cannot tell you how many times ML engineers left the field of ML engineering because they realized it was more about show and tell than actually providing results that matter to people. And I hope, you know, that gets to be your story. So what's next? You tell me. I didn't come here to give you a hot take definitive answer on anything. Honestly, what matters to me is like, one, do you even care about what I just showed you? Is this your story? Does anything excite you? You know, like what scares you? Which out of the 3 you're like, ugh, I don't want that in my life, right? You don't have to say that out loud right now because you're on live stream. But let me know what your honest opinions are at the booth later today. But that's about it. I mean, we got 8 minutes for questions, so come on over, all right? And when you do ask a question, someone's going to bring a mic to you, all right?
Hey, which ML algorithms does the second demo support?
Let's see. These 10. I'm going to be honest, I don't know what they really, really mean. Talk to the continual people over there if you want a real answer.
Thank you.
Cool. Also, I forgot to share this. The reason why I had this talk is because I already wrote a blog for this, and I was lazy, and I was like, oh, I'll just do this in a 30-minute public speaking form. And so if you don't want to watch this recording, QR code this blog, and it goes into much more depth than even what I just did in the past 30 minutes. Huge shout out to Izzy for co-authoring it with me. All right? Ooh, I'm going to do this. People on the live stream won't be able to see this, but I want to do some hot takes. Which of you think this was the best out of the 3 demos? Raise your hands. Okay. I'm going to do another one. Which one of you think this was the best out of the 3 demos? Raise your hands. Okay. Which one of you think this was the best of the demos? Oh, wow. Okay. Okay. All right. Cool. That's it. That's enough spicy questions. All right. Let's keep going. I mean, if not, you want to digest, you want to have a heart-to-heart, meet me at the DBT Labs booth, and we'll go from there. But thank you so much. Appreciate your time.